logistic regression. So before we start, we are going to set the stage with our previous knowledge about regression. If you remember, when we talk about regression, we essentially think of a linear combination of what? So we say the intercept is w naught, and it is going to go with x naught, which is a vector of 1, 1, 1, 1, 1, and then we plus w1 is the coefficient for the second variable x1. It has some values 0.59, whatever, and then w2 is for x2, and so on. As many independent variables we have, as many coefficients we get in linear regression. We summed this equation up as wx multiplication, or we can also write it as w transpose x. Till that point, we are on the same page, right? So this is our current knowledge about regression. We do what? We try to find suitable values for these w's. We call them the coefficients of regression. Each coefficient gets multiplied with the value, if we are looking at this example, and w0 gets multiplied with 1, w1 gets multiplied with the value of x1, and so on. We add them up. This operation we represent as w transpose x. It gives us what? So w transpose x gives us what? The estimate of dependent variable. We represent it using a hat, y hat. So x in the set of independent variables, w set of coefficients for each variable. We multiply them, sum them up. It gives us the estimate for dependent variable y. Till now, the story is intact, but it's going to get twisted a bit because we are going to consider a problem where y is not a numeric variable but a categorical variable. For example, it can contain only two values, male, female, or fail, pass, or 0, 1, or multiple values, 1, 2, 3. So there are discrete values that this dependent variable is taking. If there are only two values, then we need to classify one given example based on the independent variable values. We need to classify it. Either this example is male or female, or male or male. So we have this problem now. When we have discrete values in the dependent variable, our problem changes to classification problem. Till now we have been doing successfully regression, but what about classification? So you will see today that we are going to use same w transpose x for classification with the help of an amazing function that is going to convert our w transpose x on x-axis. If we put the result of w transpose x, y-axis will be values ranging between 0 and 1. So these values, w transpose x, will be transported from the range of, maybe if your range is 100 to 1000, for example, is going to convert those values into 0 and 1. So for a value here, 500, the corresponding value will be 0.5 using this function. Are you interested in learning this function that converts your linear regression solution, a solution that looks like linear regression solution, a linear combination, into a classification solution? If you have any question till now, please ask. Any doubts? All right, then what we are going to now essentially do is classification. when we need to do classification, when the dependent variable is categorical. If it can take only two values, we say we are doing binary classification. If it is allowed to take multiple values, more than two, then we are doing multinomial classification or multi-class classification. First, we start with binary, and at the end, we can extend this to multi-class problem very easily. So, how we convert this W transpose X to a classification decision is based on a simple equation, which is 1 over 1 plus exponentiating W transpose X with minus sign. It will convert it back into a number. That number is going to give us the decision whether X belongs to class A or class B. So, before we discuss that equation first, let's look at an example data. Here we have three variables: math, a column of math scores, and we have reading score, and we have gender of the student, and we want to predict what? Whether the student is in honors class or not. So honors column is having values like this. And every row, math score may be 59, 78, female 1, 49, 98, female 0. When female value is 0, it means the student is male. 59, 77, 0, and this kind of data we have. So we want to predict based on the score in math and the score in reading and the gender of the student whether the student is in honors class or not. So when we look at the equation that I told you, it's a W transpose X equation. The coefficient for math is here. The coefficient for reading score is here. And the coefficient for female score is here. The intercept of the model is here. In case of linear regression, these numbers mean that if one unit change in independent variable will cause let's call this independent variable x1. So if we change x1 one unit, will cause change in y, the dependent variable y. How much? As much as w1. So the coefficient represents, in case of linear regression that we have already done, linear regression tells us that a one unit change in independent variable x1 will cause change in dependent variable y as much as w1. So w1 is 1.5, for example. In that case, dependent variable y will change 1.5 times the change in x1. This is the interpretation of linear regression coefficient. In case of logistic regression, our weights, our coefficients are going to give us a different interpretation. And that is, for the math score, we are going to read the model like this, keeping read and female constant. So they don't change. We change only math score. One unit increase, let's say if student has 40 score and we change it to 41, one unit increase in math score increases the odds of being in honor class by how much? As much as this coefficient. So when we look at this coefficient, it represents log of odds ratio. So ratio, if we get 40 score, what are our log of odds to be in honors class? If we change it to 41, what are our log of odds in being in honors class? If we take ratio of both numbers, that number is represented by the coefficient. So the key word here is log of odds ratio. In case of linear regression, the coefficient values represent the time as much as W1 times. So Y changes how much? As much as the coefficient times value of X. In case of logistic regression, the log of odds ratio changes how much? As much as this. In case of read, let's practice keeping math and female constant. 1 unit increase in read score increases the odds of being in honors class by as much as the coefficient of the read exponentiated. If we don't exponentiate it, then it is log of odds ratio. But when we exponentiate it, we just get odds. For the female, keeping read and math constant, females have 0.97995 exponentiated. Whatever the value comes, that much better odds than males for getting into honors class. So understanding how to read a logistic regression model, which looks like a regular regression model W transpose X, but it is not a regular regression model. Linear regression coefficients talk about number of times dependent variable changes with respect to independent variable. In logistic regression, we talk about log of odds. Now, you must be interested in revising what are odds, what is odds ratio, and for that, let's revisit few of the concepts that we have there for probability, odds, log of odds, and odds ratio. For the probability, we all know that it is about number of times we want to observe an event of interest, let's say number of females in school divided by total students, will give us the probability of female in school, which is represented by P. Now, this can also be represented using this equation, odds divided by 1 plus odds. What are odds? Odds are the probability of event of interest divided by the probability of other event. So the probability of event of interest is finding the probability of females. Let's say it's 0.7, and divided by probability of males will be 0.3. So odds of finding a female in the school are 0.7 over 0.3. Okay? And interestingly, we can represent odds with this expression, which is exponentiating your W transpose X. Your linear model, linear combination of weights and independent variables multiplied and summed together. If we exponentiate it, we get odds. And if we take log of odds, we will take log of exponentiated W transpose X. So log will cancel E. So here, odds divided by 1 plus odds is the probability. You can see P over 1 minus P is odds, and 1 plus P over 1 minus P, we get probability. Right? And here we saw that e raised to power W transpose X is odds. So 1 plus odds is 1 plus e raised to power mx plus b, which can also be written as 1 over 1 plus e raised to power minus W transpose X. So there is a connection between probability and this function, and this is the function that is going to transform our W transpose X into 0 and 1 probability. This function, when we plot it for all possible values of W transpose X, it looks like X. We refer to this function as sigmoid function. Now let's look at log of odds a little closer. Log of odds are what? We know that odds are P over 1 minus P. When we take log, we also know that P over 1 minus P is e raised to power W transpose X. We take log of e raised to power W transpose X, log cancels e, we get W transpose X out, and which is equal to something, we are going to call it the logit of P. Log of odds are equal to W transpose X, which is referred to as logit of the probability. The range of these values are between minus infinity to plus infinity. On x-axis we have minus infinity to plus infinity, and it squashes all these values into the range of 0 to 1. Now, the third concept, odds ratio, is very straightforward. Odds of event 1, let's say if we have score 40, what are the odds being in honors class? Odds 2 is, for event 2, if score is 41, what will be the odds? So their ratio is referred to as odds ratio. Alright, so the odds ratio is going to represent the W's in our model, right? So for the coefficient for reading score is going to give us the odds ratio. If we have 40 score or 41, how much better are our odds? What is the ratio of our odds? Is it improving or decreasing by changing the variable values? Will be explained. How much it is changing as much as the coefficient of that variable. So far so good. Now, how do we get these values? How do we get these values is a problem of estimation. There are multiple ways to estimate the values of W to get the best possible coefficients. One is analytic way, and second one is using an algorithm like gradient descent and iteratively trying to find the best possible solution. So if you are interested, how do we calculate these values? You are going to attend to the binary classification logistic regression discussion that I provide you here. Other than that, now we are going to look at some of the interesting things about logistic regression. So if we now want to predict the gender is 1, female, read score is 59, math score is 88. In that case, we will multiply math with 0.1229. We will multiply read with the 0.059. We will multiply female with 0.97, and then we will add this number here, and whatever number comes out, W transpose X, represents the log odds of this person who is female, who have 59 score in reading, 88 score in math log odds of that person being in honors class. So remember, W transpose X, here I'm talking about mx plus b. B is the intercept, m is the slope, but in short we can write it as W transpose X is equal to log of odds. So a logistic regression model predicts what? It predicts log of odds of an instance, an example, a row in our data to belong to the class of interest. The class of interest here is being in honors class or not. So I also provide some interesting examples here that you may like to read on your own and try to make sense of this modeling technique using a data set that is provided here. You can also access it from here on my GitHub, and with no variable, with one independent variable, with the categorical predictor, how we can match these numbers by manually calculating the log of odds and then matching them to the coefficients that we have. Do they match? If they match, then it will confirm your understanding of the interpretation of the model and how it works. One interesting thing that you want to notice in logistic regression, you can input categorical variables and numeric variables together. So here we have math, which is a numeric variable, read, which is a numeric variable, female is a categorical variable, right? So 0.97 represents the change in log of odds ratio if the person is female. So we exponentiate it, we get a number, and that number represents how much females are more likely to be in honors class. How about males? How do we calculate the likelihood of the other value of a female column? In female column we have 1, 0, 0, 1. 1 represents female, 0 represents male. So when the value is 0 for this column, we multiply that with 0.97. So the remaining value is coming out of these variables, right? So when female is 0, we are looking at the log of odds for male students. In case read is also 0, in math is also 0, female is also 0, the log of odds for a male student being in honors class will be exponentiation of this value. So intercept represents the other levels of categorical variables in our equation. So here we have just one categorical variable, female, and the other level 1 is represented for gender female, level 0 is representing gender male. So all other levels that are not here, they are represented by this intercept. Okay.